Hello everybody and welcome to the fourth practice video for two-dimensional vectors. So in the first question we're given the triangle OAB and we're told the point A has coordinates 6, -8 and the point P has coordinates 4, 1. We're also told that P lies on OB so that OP to PB is in the ratio 4 to 1. And also point Q lies on AB so that AQ to QB is in the ratio 3 to 2. Also, the line OA is extended to reach point R so that OA to AR is in the ratio 5 to 3. Now for part A, we want to find the coordinates of Q, so we need to find the vector OQ. Well, you can see from the diagram that OQ is going to be equal to OB plus BQ, but we don't know OB or BQ yet, so we'll have to find those first. Well, if we look at OB, we can see that it's split up into the ratio 4 to 1, which is the same as saying it's split up into 5 sections of equal length. Now, 4 of those sections are equal to OP, so OP is 4/5 of OB. And rearranging that, we get OB is equal to 5 over 4 times by OP. And 5 over 4 times by OP, which is 4i plus 1j, is equal to 5i plus 5 over 4j. Next, we have to work out BQ, which is on the line BA, and as you can see from the diagram, BQ to QA is in the ratio 2 to 3, which means that BA is split up into 5 sections of equal length, and BQ is 2/5 of that, so 2/5 of BA. However, we don't yet have BA, which again, looking at the diagram, is going to be minus OB, because we're going in the opposite direction from B to O, plus OA. Now, putting those values in, you should end up with BA equal to I plus minus 37 over 4J, and then we can work out BQ by putting that value in for BA, and we get 2/5 of I minus 37/10 of J. So now we can work out OQ by substituting in the values for OB and BQ, and we get 27/5 of I minus 49 over 20J. So the coordinates of Q are going to be 5.4 and minus 2.45. For part B, we want to find the vectors PQ and QR. So starting with PQ, you can see that that's going to be equal to PB plus BQ. However, we don't yet have PB, but as we discussed earlier, OP is 4/5 of OB and PB is 1/5 of OB. And we know OB, so we can work out that PB is equal to I plus 1/4 J. Now we worked out the value for BQ in part A, so we can now calculate PQ by substituting in the values for PB and BQ, and we get 7/5 of I minus 69 over 20J. And to work out QR, we add QA and AR. Now QA is 3/5 of BA, which works out to be 3/5 of I minus 111 over 20J. And AR is 3/5 of OA. Now, if you get a bit confused here and say, well, that line's split into 8 different sections, yes, it is, but that's from O to R. So AR is effectively 3/8 of OR, which is also the same as 3/5 of OA. So AR works out to be 18 over 5i plus 24 over 5j, and now we can work out QR by substituting the values back in for QA and AR, and we get QR is equal to 21 over 5i minus 207 over 20j. And in part C, we're asked to show that PQ and R are collinear. So if we get the two vectors PQ and QR together and compare them, we know that if one is a scalar multiple of the other, they're parallel. And if they share a common point, Q in this case, then they'll be collinear or on the same line. And as you can see, QR is exactly 3 times PQ. So P, Q and R are collinear as they share the point Q, and QR is a scalar multiple of PQ. and the ratio PQ to QR is 1 to 3. Well, this question's already taken 5 minutes, so I'm going to have to leave it there for this video. But thanks very much for watching, as always. And if you could press that like button, that would be great. And subscribe for more videos like this. Hope to see you on the next one.